All right, taking a look at 32. The sequence -1 to the n times 1 minus 1 over n. Okay. As n gets very large, 1 over n is going to get really small, so this is going to behave like 1 times plus or minus 1. It's going to keep bouncing back and forth between something very close to positive 1 and something close to -1. I think that it diverges. Not to infinity or negative infinity, but it just does not converge. Okay. Well, let's see if we can argue this. Since for any L in R, there is no n in the natural numbers such that the difference between our sequence, -1 to the n, 1 minus 1 over n, and L is less than, now we need to choose some number. Now I've thought ahead a bit. The first time I tried this, by the way, I used 1/2, and I didn't like what I got, so I'm going to try a smaller epsilon, a particular thing, epsilon. And so I'm going to try 1/4 this time. I think that that'll work out. Okay, so the idea is you can't have this inequality hold for all values of n bigger than n simultaneously. Okay, let's see. I'll use a semicolon. I'll say let this odd number 2k minus 1 and 2k, so that's two consecutive numbers. This is an odd number, and this is the next number up, which is even. Be bigger than n. Okay, that is to say, if you choose some particular value of n, and then have 2k minus 1 and 2k both be bigger than n, then right. In order for this to hold for all values, for all integers bigger than n, we would need the following two inequalities to hold simultaneously. All right, system of inequalities. Okay, first off, I'm going to put in the system here with, rather the inequality here, with n replaced by 2k minus 1. Now that's odd, so that I'll definitely get a negative sign there, giving me a 1 over n minus 1 minus L is less than 1/4. And also, with 2k, that would give me a positive sign there, so I'll get a 1 minus 1 over, oh, I'm sorry, I shouldn't be putting in n. I should put a 2k here, and I should put 2k minus 1 there. Okay. That less than 1/4. Now, if there were some capital N such that this difference is less than 1/4 for all lowercase n bigger than that, then with these two particular values of lowercase n, 2k minus 1 and 2k, both of these things would hold simultaneously. I'm going to show that they can't hold simultaneously. So let's take a look at that system. It's equivalent to the system, let's see, I can put 1/4 on this side, say 1/4 is bigger than, and I'm going to change the order of L and the nth term of the sequence, just I think it will be helpful. Of course, I could swap an and L here, you know, and just get a minus sign, and the absolute value would cancel out that minus sign. L minus 1 over 2k minus 1, and let's see, that would all change this to a plus 1. All right. And that should be bigger than 1/4, right? So the idea is this thing right here is between 1/4 and negative 1/4. Well, the guy right here, L minus 1 plus 1 over 2k, that also is between 1/4 and 1/4. So the idea here is to see what kinds of restrictions that puts on L. So I'm going to isolate both these inequalities for L. And when I do that, we will be able to see something quite nice. So let's see, if I put L by his lonesome here, I'll have things on either side of the inequalities. On the left, I'll have 1/4 plus 1, which is 5/4. And I'll have to add, oh, let's see, I need to subtract 1 from both sides, so I made a mistake. Not 5/4, subtract 1 from both sides to give me negative 3/4. Okay, and then I have to add 1 over 2k minus 1. And then over here, I have to subtract 1 to give me negative 5/4. And then add to that 1 over 2k minus 1. All right. The second inequality there, L. All right, now this time I add 1 to both sides. That's the 5/4 I was looking for. And this time I subtract 1 over 2k. And over here, negative 1/4, whoops. Add to that 1, and I get 3/4. And I have to subtract from that 1 over 2k. Now, here's what I'm thinking. I'd like to remove k. So, what I'll do is I am going to think about putting an extra inequality sign right here. What could I put if I put a greater than sign right here? And if I had L and I had, less than sign right here, and then that expression, what is even smaller than that? Ah, I know. Look, this is negative 5/4 plus something. You want something even smaller than that? Then just have negative 5/4. Right? So here I need to think for a second about what I'm going to imply. Is this going to imply that, or is that going to imply this? Well, if L is greater than that, no, I think it only goes that way. Okay. Now, similarly, I am going to write something even bigger than negative 3/4 plus 1 over 2k minus 1. So I can't just remove that because I need something even bigger than this whole expression. I can't remove the 1 over 2k minus 1. Let's see. The biggest thing I could be adding is, well, the biggest possibility, I suppose, is k when k is 1, and so the denominator is 1. So the biggest thing I could be adding is 1. If I were adding 1, that would give me negative 3/4 plus 1. That would give me negative 3/4 plus 4/4. That would give me 1/4. Okay. So this inequality is stronger than this one. But if this holds, then this one definitely holds. Right? The weaker one implies the stronger one. And then we want to play similar games for the second inequality. Over here, I'd like to replace 5/4 minus 2 over k with something even bigger than that. Well, okay, so I just won't subtract 1 over 2k. I'll just write 5/4. And then over here, 3/4 minus, let's see, 3/4 minus the biggest thing that I could be subtracting is 1/2. Right? And so if I want something even smaller than this, then how about if I subtract just 1/4? Right? So instead of subtracting 1/2, I'll subtract 1/4. Instead of subtracting the biggest possible thing, I'll subtract something even smaller than that. Rather, something even bigger than that. So let's see, 3/4. I will subtract, 1/4 will be the result. Right? Subtract the 1/2. So this pair of inequalities has no solution. Right? There is nothing between 5/4 and 1/4, which is also between 1/4 and -5/4. 1/4 doesn't work because we didn't have an equal sign here. Okay, and that's all that's required, is that no matter how big n is, we can find two lowercase n's such that the system of inequalities that result from using those two lowercase n's here gives an incompatible system of inequalities.